What's up, open school algebra class? Mr. Kim here with some two-step equation review. So as you know, when we're working with two-step equations, get this erased here, whoops again, twice, there we go, get it all erased. So we're working with a two-step equation. There's an order of operations that we need to follow. So in the equation 5 plus 3n equals 14. First thing we always need to remember is that the number that's hanging out here, we have to get rid of it, move it to the other side, so that we can isolate the coefficient and the variable. So by doing this, we look to the front of the number here, and we try to figure out if there's a sign there. And if there's no sign there, it's always positive. We always look to the front. We don't care about what's back behind it. We just look to the front of the number. So we see there's no sign, so it's positive. And so in order to get rid of that positive number, we'll get some of this out of there. In order to get rid of that positive 5, we're going to subtract 5. And whatever we do to one side of the equation, we have to do to the other side of the equal sign. So we're going to move this equal sign down so we see one side versus the other side of the equation. So when I subtract 5 from the other side, now I'm going to go ahead and I'm going to cancel, because 5 minus 5 is just 0, and 0 plus 3n, 0 plus 3n just equals 3n. So we don't care about that 5 minus 5. Once we've taken it away, it just zeroes it out, and we don't have to replace it with a 0. Just for the ease of keeping our paper kind of nice and clean, we just go ahead and we say it's gone. But it's not gone from the other side until we subtract it from 14. So we have 14 minus 5, which equals n, which equals 9, not n. We got 3n equals 9. Very important to be able to read our algebra equation. Anytime we have nothing between the coefficient and the variable, there's nothing between there, it always means multiply me. So this reads 3 times n equals 9. And if it's 3 times n equals 9, now I have to figure out what I have to do: the inverse operation, the opposite operation, or the undo operation on the 3 times n. Well, the opposite of 3 times n is to divide, so I divide by 3. And when I divide 3 by 3, how many 3's are in 3? There's exactly 1. And 1 times n is just n. So just like when I had 0 plus 3n, it was just 3n. 1 times n is just n. And so I go ahead and I would drop the n down. Now on the other side of the equation, I divided this side over here by 3. So on the other side of the equation, I have to divide the 9 by 3. And when I divide 9 by 3, pretty sloppy 3, I'm almost out of room on my iPhone. When I divide that 9 by 3, I ask myself how many 3's are in 9, and the answer is 3. So n will equal 3. So I'm going to go ahead and I'm going to do this problem again, this 5 plus 3n equals 14, but this time I'm going to change it up a little bit. I'm going to erase it. 5 plus 3n equals 14. So we got, we got 5. Okay, so we're going to go ahead and we're just going to redo it. 5 plus 3n equals 14. And this time what I'm going to do is I'm going to make this 5 a negative 5. So right here in the front of the 5, it's now negative 5, pretty sloppy negative, let me clean that up a little bit. it's negative 5 plus 3n equals 14. So again, I have to look in front of the 5, and when I do, this time I see that there is in fact a negative sign there. So the undo operation on this is going to be to add 5. If I have negative 5 plus 5, I again create a situation where I'm adding 0 to the 3n. And when I'm adding 0 to the 3n, I just have 3n left. So I'm able to cancel this. And now I go over to the other side and I have to add the 5 back in. Now 14 plus 5 is 19. And so I end up, when I carry my equal sign down, I drop the 3n down, and I'm left with 3n equals 19. And again, when I read this, I read 3 times n equals 19. 3 times n equals 19, and so I divide by 3 as the undo operation. 3 divided by 3, it goes in 1 time, and 1 times n is just n. And 19 divided by 3, okay, I don't have my calculator in my hand. I could pull it up right now, but you can go ahead and do that as well. And n will equal 19 divided by 3. Now, I want to reflect on this, where we're at right now in this equation. Now, some of the students that we have in our algebra class, they want to work the problems in their head. Now, I'm pretty good with mental math, but I can't tell you what exactly 3 divided by 19 is. Well, I can do it as a, actually I can do this one. I know that there are 6 3's in 18 with 1 remainder, so it would be 18.333 with a continuing, or excuse me, it'd be 6.33 with a continuing decimal. Now, mental math will get you so far, and when we continue to look to mental math to run these equations down, and we're just going back to here, and students that we have just think, okay, well, I'm going to subtract 5 from this side, then I'm just going to divide in my head and I'm going to solve it. Well, at the point that we're at right now with one-step equations, you might be able to get away with that. Certainly on the last problem you could. But as we progress into more and more complex equations, you're not going to be able to simply mentally divide, add, subtract, and multiply everything that you're going to have to do. So the good process right now, the discipline process, the process for your future, is to go ahead and carry all of those steps down. Plus 5, cancel, plus 5, carry the 3n down. 14 plus 5 is 19. 3n equals 19, divide by 3, and go ahead and carry it right on down the paper. Let's look at another one, and this time let's put the variable and coefficient first. So in this example here, I'm going to have 2n plus 5, 2n plus 5, and I'm going to have this equal 20 right there. That'll do me right there. 2n plus 5 equals 20. So again, I'm going to go ahead and I'm going to draw a line down my equal sign. I'm going to look to the first step of this operation is to get rid of the number that's just hanging out here on the side with the coefficient and the variable. It's a plus 5. So in order to get rid of that, I've got to subtract 5. And when I subtract 5, plus 5 minus 5 becomes 0 again. And 2n plus 0 is just 2n. So all I worry about dropping down is a 2n. And then I send my equal sign over, and I have 20 minus 5, and I end up with 15. 2n equals 15. So I have, here I have 2 times n again. So when I divide away the 2, 2 divides into 2 one time, I'm left with 1n, which is the same as n, and 15 divided by 2. When I drop the n down, I've got n equals 7.5. 7 can't get the point in there. There's a 7 point. Come on, give me a point. 7. And there's a point in there. Here, I'll do it with a laser pointer. Having trouble getting a point in there. I've run down out of my iPhone whiteboard again. 7. There, I'll put my point up there. 7.5. And that's how that rolls. Hang on a second. I'm going to let my cat outside. Flip my iPhone a couple of times for you there. So let's look at another problem, and this time let's move the coefficient and the variable to the other side of the equation. Not the best. Okay, so if I have, I'm just going to have 5 equals 7n minus 3. So I have 7n minus 3. Now this is a little different. This time the coefficient and the variable are off to the right side of the equal sign, but the steps are still essentially the same. I go ahead and I draw my barrier down for one side of the equation versus the other, and looking right in front of the 3, I see that it has a minus sign. Now I can take this to be a negative 3, or I can take this to be minus 3, or I can take this to just be whatever the quantity of 7 times n is, has to have 3 subtracted from it. But when I deal with this 3, I actually take it and the sign in front of it again, the sign that's in front of it, and I deal with it as a connected unit. So if I'm minusing 3 from 7n, the way to undo that is to add 3. Minus 3 from 7n, taking away 3 from 7n, subtracting 3 from 7n. When I add 3 back in, I'm creating 7n minus 0, which essentially gives me 7n once again, 7n. So now everything is done on that side of the equation with the number that was hanging out with the coefficient and the variable. So I move to the other side and I add plus 3. Here I had to add plus 3 to get rid of the minus 3. So I add plus 3. 5 plus 3 is 8, and I go over 8 equals 7n. Oops, 7n. There we go. Pretty sloppy. I'll correct that there. 7n. So I have 8 equals 7n. And now I have 7 times n. And if I have 7 times n, the undo operation is to divide by 7. When I divide by 7, 7 divided by 7 goes in exactly 1 time, and I'm left with 1 times n, which is the same as the n. Then I take my 8 and I divide it by 7. Can't do that very well. I'll just move that up. 8 divided by 7. and however many times 8 goes in, it'll go in exactly 1 and 1/8 remainder, and 1/8 is 0.125, I believe. I'm just doing this mentally, which is what I told you not to do. So the answer is n 1.25. I'm going to go ahead and I'm going to pretend I'm writing this at the bottom. So I go 1.25 equals n, and by convention, after I have 1.25 equals n, I write the variable first for the final answer, n equals 1.25, and I draw a box around my answer so the teacher can find the answer on my messy paper. So that's a look at what the steps are. First step is subtract, in this case the 5. Second step is to do the division of the coefficient to isolate the variable on one side of the equation. Hope this helped.